Section 9.3 continued. Graphing rational expressions. These are the guidelines for graphing rational expressions. Use these when you complete your assignment. Number 1, we want to simplify f if possible. Number 2, find the zeros of the denominator if there are any. If there are any, we know that those are the vertical asymptotes, and we want to sketch those on our graph. Number 3, find and sketch the horizontal asymptotes if we have any. Number 4, find and plot the y-intercept if they have any. We can do that by finding f of 0. Number 5, find and plot the x-intercepts by finding the zeros of the numerator if we have any. Number 6, we want to plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. Actually, we'll probably have to plot a couple to actually see what the graph looks like. Number 7, we want to use a smooth curve to complete the graph. Our first example, I want to graph the function f of x equals 3 over x minus 2. Following the guidelines, I want to simplify. It's already simplified. Number 2, I want to set my denominator equal to 0 to find the vertical asymptotes. And when I do, I get x equal to 2 as my vertical asymptote. And I can graph that. Number 3, I want to find my horizontal asymptote. And since I have a degree in my denominator larger than the degree in my numerator, I have a horizontal asymptote at y equal to 0. And I can plot that. Number 4, let's find the y-intercept by finding f of 0, or just replacing x values with 0. 3 over 0 minus 2 equals a negative 3/2. And my intercept is 0, comma, negative 3 over 2. And I can plot that. Negative 1.5. And I can continue on to 5. I want to find my x-intercept. I just let f of x or y be 0. That eliminates my denominator, or 0 equals 3, which is not possible, so I have no x-intercepts. Now I want to find values of points depending on where my y-intercept and vertical asymptote are. Therefore, I'm going to find a value of negative infinity to my y-intercept, which is at 0. So negative infinity to 0. So I want to find a point anywhere in this area. I'm going to choose negative 1. So my x value is a negative 1. When I plug that in and solve, I'm going to get my y value of a negative 1. So the ordered pair is negative 1, negative 1, negative 1, negative 1. Then I want to find a value between my y-intercept and my vertical asymptote. That would be between 0 and 2. A value between, x value between 0 and 2, I can choose 1. And when I do that, I'm going to get a negative 3. So my ordered pair is 1, negative 3. And I can plot 1, negative 3. And I think we're good on this side. I think we can see that my function on this side is going to decrease from negative infinity to my vertical asymptote. Now we need to find points on the other side of my vertical asymptote. So let's find values that are going to be from my vertical asymptote, which are 2 to positive infinity. And I probably need to find 3 values. I'm going to choose values of 3. And when I choose 3, I'm going to get 3 out. My ordered pair is 3, 3. And I can plot that. And I can now select 2 more points. Let's choose 4. And when I plot in 4 for x, I'm going to get 1.5. And let's do 5. I'm going to get 1. 5, 1. So my ordered pairs are going to be 4, 1.5, and 5, 1. And let's see if we need to choose any more after I plot those. 4, 1.5, and then 5, 1. And I think we can see that my function is going to decrease from my vertical asymptote of 2 to infinity. We're just going to do 3 more examples. Here I have a function f of x equals 2x minus 1. We can try to simplify, but it's already simplified. So number 2, we want to find our vertical asymptote. To do that, I just want to set our denominator equal to 0. So vertical asymptote, x equal to 0, and that's my vertical asymptote. I'll graph that in a bit. Let's go to 3. I want to find my horizontal asymptote, and I can see that my degree of my numerator and denominator are equal. Therefore, the value of my horizontal asymptote is going to be y equals the coefficient of the largest degree in the numerator over the largest degree in the denominator, which is 2 over 1, or y equals 2. And step 4, I want to find my y-intercept. So I find the value of f of 0, which is going to be 2 times 0 minus 1 all over 0. And you can see I'm going to get a negative 1 over 0, which is undefined. So I have no y-intercepts. Number 5, I want to find my x-intercept. To do that, I set my y, or f of x, to be 0, and that eliminates my denominator, and I have 2x minus 1 equal to 0, and 2x equals 1, or x equals 1/2. So my x-intercept would be 1/2, 0. Let's plot what I have. I have a vertical asymptote at x equal to 0. I have a horizontal asymptote at y equal to 2. I don't have a y-intercept, but I have an x-intercept at 1/2, 0. Now I need to find values in a interval range, or my test range, from negative infinity to my vertical asymptote of 0. So I need to find 3 values to the left of my vertical asymptote. So somewhere in between a negative infinity and 0, I need to find 3 values. I'm going to choose a negative 1. When I choose a negative 1, I get 3, and that's the ordered pair I get. So negative 1, positive 3. When I choose a negative 2 in this same test interval, I'm going to get a y value of 5/2, or 2.5. So when I plot that, I'm going to have negative 1, 3. And I'm going to plot a negative 2, 2.5. Now I really need to check and see what's going on in between -1 and 0 to verify that this is going to keep on increasing as I approach my vertical asymptote. So I better find another value, and that value I'm going to choose to be a -0.5. And when I get a -0.5 plugged in, I'm going to get a +4 out. And I'll plot that to see what that looks like. -0.5, 1, 2, 3, 4. That tells me that my line is increasing, or my function's increasing. So I can just put on a smooth curve from -infinity to my vertical asymptote. My function increases. Now I need to go to the right of my vertical asymptote and find values between 0 and 0.5, and also between 0.5 and +infinity. So between 0 and 0.5, I can choose 1/4, +1/4, and I get a -2. And when I choose from 1/2 to infinity, a point in between 1/2 and infinity, I'm going to choose a +1, and I'll get a +1 out. Now I can plot those values. I have 1/4, 1/2, and when I plot 1, 1, I can see that the value is going to decrease from +infinity to 0. Our next example, I have the function x over x squared minus x minus 2. To begin with, I need to simplify. So I have step 1, I have f of x equal to x over, when I factor, I'm going to get x minus 2 times x plus 1. Now what I need to do is to find my vertical asymptote. To do that, I'm going to set each quantity in my denominator equal to 0. So x minus 2 equals 0. And I'm going to get x equal to 2. And x plus 1 equal to 0. And x equals a -1. Those are going to be my vertical asymptotes. Step 3, I need to find my horizontal asymptote. And since my degree of the denominator is bigger than the degree of the numerator, I have a horizontal asymptote at y equal to 0. That's my horizontal asymptote. Now on step 4, I need to find my y-intercept, which is going to be f of 0 equals 0 over 0 squared minus 0 minus 2. And I get a value of 0 over a -2. So I have a y-intercept of 0, 0. Now on step 5, I want to find my x-intercept. And I set my numerator equal to 0 because it would eliminate my denominator either way. So I would get x equal to 0. And my 0, 0 is my x and y intercept. Now what I can do is plot some of the information I already have. I have a vertical asymptote at 2 and -1. And I determined that I have an x-intercept and a y-intercept at 0, 0. Now it looks like I need to find quite a few values. I need to find 3 values from an interval from -infinity to a -1. I need to find at least 2 more values between my vertical asymptotes of a -1 and 2, and at least 3 values from +2 to an infinity interval. Let's begin by using the interval between a negative infinity and -1. And I'm going to find 3 points in that interval, and hopefully that can determine what my graph looks like in that area. So I'm going to choose a -2, I'm going to choose a -3, and ultimately I need to choose a closer value, which is a -1.5. And when I find those values, I get a -0.5, I get a -0.3, and I get a -0.9. Now I can plot points in those intervals, and when I do, I'm going to get a -2, -0.5, I'll have a -3, -0.3, and I have a -1.5, -0.9. And I can see that my function will decrease from -infinity to a -1. Now I need to find values into an interval between a -1 and 0. And when I plug in a value between a -1 and 0, I chose a -1/2, and my x value of a -1/2 is going to have an output of a +0.4. My next interval I need to find is between 0 and 2. Between 0 and 2, the easiest one to find would be an x value of 1, and it has an output of a y value of a -0.5. And I can plot those. So I'll have a -1/2 0.4, and I'll have one -0.5. And you can see from the -1 asymptote to the 2 asymptote, x equals 2 asymptote, I'm going to get my value of the function decreasing. Now I need to find 3 points in the other interval, and that interval will be between a +2 and infinity. And I did choose 3 values. I chose 3 with an output of 0.75. I chose 4 with an output of 0.4. And I chose 2.5 with an output of 1.3. And then I can plot those values. And that's going to look like this: 3.75, 1, 2, 3.75. That's going to be 4.4, 1, 2, 3, 4.4. And my last one on this one is going to be 2.5, 2.5, 1.3, 2.5, 1.3. And I can plot that with a smooth curve. And that function, part of the function, is decreasing from my vertical asymptote of 2 to infinity. On my last example, I have a function of f of x equals x squared minus 9 over x squared minus 2x minus 3. I want to begin by simplifying. So f of x, factor the numerator, I get x plus 3, x minus 3, over, when I factor, x minus 3, x plus 1. This will simplify, so my simplified version of the function is going to be x plus 3 over x plus 1 when my x minus 3 is canceled. Step 2, let's find my vertical asymptotes. So I set each denominator quantity to 0, x minus 3 equals 0, x equals 3, x plus 1 equals 0, x equals a -1. But my x minus 3, since it got canceled from my simplification, that does not become an asymptote. This becomes a hole in my graph. It's undefined, but it's not a vertical asymptote at that point. My x plus 1, since it didn't get canceled, is a vertical asymptote. So I have a vertical asymptote at x equal to a negative 1. Step 3, I want to find my horizontal asymptote, which is the degree of the numerator and denominator. Since the degree of the numerator and denominator are the same, it's the fraction of their highest degree coefficients, which would be 1 over 1. So I have a horizontal asymptote at x equal to 1. Now I want to find my y-intercept, so I'm going to let x equal to 0, and when I simplify and plug in 0 for x, I'm going to get a negative 9 over a negative 3, which is 3. So my y-intercept is at 0, 3. My y-intercept and my x-intercept, I'm going to set 0 equal to my numerator, which is x plus 3. So x equals a negative 3. So that would be a negative 3, 0 for my x-intercept. Now let's plot some information on my graph. So let's begin with my vertical asymptote. I have a vertical asymptote x equal to negative 1. Horizontal asymptote at y equal 1. I have a y-intercept at 0, 3. And x-intercept at negative 3, 0. And if I go back and look at where my hole is at x equal to 3, I've already calculated my value for x equal to 3 by plugging into my simplified version of my function. And when I do that, I get 3 plus 3 is 6 over 3 plus 1 is 4. 6 over 4 is 3 over 2. Therefore, I'll have a hole at 1, 2, 3, 3 over 2, which would be right here. And I don't fill that in because my function's undefined at that location on my graph, and for the function also. So now I need to plot some information for the interval on the left, which is going to be values from negative infinity to a negative 1. And I chose values of a negative 1.5, which is approximately 3, and also a value of a negative 4, which I got to be 1/3. And when I plot that, negative 1.5, negative 1, 2, 3, and 4, 1, 2, 3, 4, 1/3, that gives me a pretty good look of my function from negative infinity to a negative 1. Now I need to plot another point from my negative 1 to infinity, positive infinity. And from there, I chose a negative 0.5. And a negative 0.5, I got 5. So a negative half, 1, 2, 3, 4, 5. And that gives me a pretty good look of my function from a negative 1 to positive infinity. And notice I still did not fill that in because my function's undefined at that location.